Good morning, students. Myself, Dr. R. Lagesh Babu, Assistant Professor, Department of Computer Science and Business System. In today's learning in machine learning, the topic which we are going to see is ensemble learning. So we are going to see what is ensemble learning, how it works, what are the advantages, how it mathematically works, and what are the application it is used. These are the topics which we are going to see in our today's lecture. So to start with, we will starting with the definition of ensemble learning. What is ensemble learning? It is a machine learning technique. It increases the accuracy and the resilience by in forecasting. That is in forecasting by merging predictions from multiple models. That is many models. It do prediction by merging prediction from multiple models. So how it does? Basically, it is getting the getting the output from each model and it combines to create a more precise predictions of the models. So there are two methods in ensemble methods. One is called the bagging and followed by boosting. Bagging is also known as bootstrap aggregation. So bagging is called is the name for bagging is called a bootstrap aggregation. So this technique is similar to random forest, but it uses all the predictors, whereas random forest uses only a subset in of predictors in each tree. This we have seen in the previous unit, random forest, and its uh, how it works, how mathematically it works for improving the accuracy of the models. In bagging, a random sample of data from the training models selected with the replacement, so which enables the duplication sample instance in a set. So this is how the basic idea behind the bagging. Now we will move how it works. By this diagram shows how the bagging works. What are the steps involved? So generally we have the original training data set. So which is divided into n sample data. We can say n sample of the original data. It is splitted into segregated separately called the sample 1, n1, n2, n3, etc. up to n. So the steps in the bagging involves generation of multiple bootstrap resamples, then running an algorithm each resample. So we have to run the algorithm for each resample to make the predictions. Then third step is called, we can say, combining the predictions by taking the average. So we are taking after getting the each sample's outputs, we are going to combine them and combining the predictions by taking the average of the predictions or taking the majority voting, or some cases it will be a voting for classification. So this is the way how the bagging works. So that will be some, we can say, algorithms or mathematical formulas, statistical formulas used for how to fetch the training data samples. From that, how we can choose how it is uniformly distributed and how the each classifier is termed, say for CI2 from the sample I. Then how we are giving the weightage for the classifier C1 to C2, CT. Now, moving to the advantages, it is a state, it does not involve deep mathematical concepts and it can able to handle the missing values very well. So that is the major advantages of bagging, we can say. And it also provides the unbiased estimates of the bagging error. So we can say because we are not to rely upon the one particular model or prediction. So we are taking the training set of resampling for each training data set. Say it's maybe N. So we are taking either average or voting for getting the predictions as well as for classification. Coming to the disadvantages, so it is even though it has some above advantages, it needs some computational expense. We have to. It is provides computational expensive for doing the sampling methods and the taking average and combining them to get the accuracy, if we improve the accuracy. To the other, several models because we are combining to get the improving the accuracy. Now, the averaging also involves makes it difficult for to interpret the final result. In some cases, it may occur. So these are all the some drawbacks in case of bagging method. Now we will move to the next method called ensemble method 2, boosting. So how it boosting differs from the bagging? Let us see. So boosting adopts a sequential approach, that is one after another. Whereas here the prediction of the current model is transferred to the next one. So the prediction of the model is transferred to the next one. So here the each model iteratively focus on attention on observations that are misclassified by its predecessor. So each model output is transferred to, that is after sampling this data set into n, sample 1, 2 up to n, the output of the one particular tree, decision tree, or we can say it is sent to the next model. So like this, it is goes on iteratively. So n models are building sequentially. The output from the current is passed to the input to the next model. Finally, only we are getting the final model, which will have the best accuracy, or we can say better accuracy in terms of it will be used for predictions, classification. So, what are all the steps of uh, ensemble method boosting? So, the idea is instead of sampling as in bagging, it will be reweigh the examples. So, we will see the steps are involved in the case of boosting. So, a subset is created from the original data set as such. Next one, initially all the data points are given equal weights. Initially, when we are assigning the weights, we are given the data points, weights, we are assigning the equal weights. A base model is created on this subset. And the fourth step is this model is used to make predictions on the whole data set. So these are all the steps involved in case of boosting. So how it works in detailed way, we can say errors are calculated using the actual values and the predicted values. So the observations which are correctly predicted, incorrectly predicted are given higher weights. Here the misclassified plus points will be given higher weights. Now another model is created with the predictions are made on this data set. This model tries to correct the errors from the previous models because it goes like a sequential way, one after another. So the similarly, multiple models are created, each correcting the errors of the previous model. So thus the boosting algorithm combines number of weak learners to form a strong learner. So this is the main idea behind the boosting. The individual models would not perform well on the entire data set. It is not practically also possible. So we are focusing well for some part of the data set, it will perform well. So thus each model actually to improves the performance of the ensemble method. So coming to the advantages, it does not require any pre-processing like EDA, exploratory data analysis. We have seen the steps to do the pre-processing and all. So here the main advantage is it does not require such any pre-processing and can handle the missing value in the data set. So it also reduces the bias. It will be reduced. It tries to reduce the effectively reduce the bias values. and it gives the prioritization of the features. So that will increase the overall accuracy during the training phase, hence reducing the computational time by some margin. So these are all the three major advantages we can say for in case of boosting. What is the drawback we can say? Hmm. It is not applicable for scalable projects. We cannot applications we cannot do scalable. It is not easy in case of boosting because of the sequential aspect, because the each model output is fed into the input of the model. So that is the sequential aspect is difficult in case of boosting. So you have any doubts, we can discuss in the upcoming classes, and you can contact me for any further doubts. Thank you. Thank you, students. Thank you.